Howdy, my name is Battery Man, and today I'll introduce you to the concept of maximum power transfer. What do I mean by that? Well, let me bring in my assistants, Resistor Man and Alessandro Volta, to help me explain. Let's say I have a circuit represented by a source voltage and resistance. Alessandro Volta, do you mind hooking us up? Now let's say I place a load resistance across the positive and negative terminals of my circuit. What should the load resistance be so that the maximum power is dissipated across it?
Let's take a moment to examine the factors at play here. Keep in mind that Battery Man and myself, the source voltage and resistance are constant. We don't change. This means that our only variable is that guy's resistance over there.
Now what else do we have to think about? Remember that the power dissipated across a resistor is the voltage across it times the current across it. Now let's examine what happens if we change the resistance. Volta, could you give me a hand?
Watch what happens when the resistance is zero. If the resistance is zero, there's a short circuit, making the voltage difference zero, which also makes the power zero. Now watch what happens when the resistance is infinite. If the resistance is infinite, there's an open circuit, maximizing the voltage difference but making current zero, which also makes power zero.
This means there must be a resistance between 0 and infinity that maximizes the power across this resistor. But what is that resistance? Well, Alessandro Volta is going to help us with some equations that would help us figure it out. First, let's find our current. Remember that current is a source voltage divided by the total resistance. Now, since we only have two resistors, the voltage is given by the voltage divider rule. Since power equals voltage times current, we can multiply these equations together to find the equation for power as a function of this resistor. Now recall that the derivative of a function is 0 at local extrema, so the resistance at max power can be found when the derivative is 0. Volta, could you please differentiate our power equation?
Thank you, Volta. Now when we solve for the load resistance, we find that it is equal to the source resistance. That means that the maximum power transferred across our load resistor is achieved when it is equal to me, the source resistor.
That's a very interesting result. Let's go ahead and test it on our circuit. Volta, would you do the honors? As you can see, the maximum power is reached when that load resistor is equal to the source resistor. Wow. Well, that's all we've got for today.